Okay, everyone. A moment, please. Uh, Unfortunately, I'm not having a microphone for no reason. We are streaming this, so this is for the stream, but we do not have a powered audio system here, so I'm gonna have to ask of all of you to stay really, really quiet during the presentation for the sake of people in the back rows so they can hear the presentation properly. Just to introduce ourselves, we are kind of organizing and trying to start the community of blockchain enthusiasts here in Zagreb. And the best way we thought we could do that was by organizing a development meetup and having you all come here and not only listen to the presentations we have to say, but actually make you meet other people who are interested in blockchains, network with them, and maybe even start your own business with the connections you've made here. But before we start, I would have to say thank you to our sponsors. There will be food and drinks later on, and this space we're here right now and the media coverage, it's been a great help to us, and I'd like to thank Hub 385, the wonderful people who allowed us to have our presentation here. After them, I would like to thank our media sponsors, Netokracija, who have kind of pushed our event on their site and made us an agenda. There are other media outlets here. I thank them as well. Since there are a couple of them I won't be naming by name, but we are really grateful for any help we can get. I would also like to thank our main sponsor, which is Electrocoin DOO. I call it Limited. Electrocoin Limited, and they're a Bitcoin exchange who've been operating in Croatia. Currently, they're the only legal way to exchange cryptocurrency in Croatia, and they've been doing millions of dollars in revenue since they've started, which enabled them to do business comfortably in this space. And they wanted me to say to all of you who are hacking on Bitcoin and other blockchain technologies that you are more than welcome to apply if you have the skills for a job with them. They are looking for people to work for them, and I thank them very much for sponsoring our event. The timetable of our event will be the following. First, we'll have the presentations. After that, we'll all go down, and there we'll have a meet and greet. We'll have pizza, we'll have beers, we'll have drinks, and hopefully you'll meet people and mingle with them. After, if our meet and greet goes into the longer hours of the night, we will move into the Pivnica Budweiser, which is a couple of minutes on foot from here, and we can continue our mingling there. Okay, just to start, I will be giving the introduction to blockchains, which is the first presentation. The second presentation will be about the Ethereum naming service, and the third presentation will be about block stacks and developing decentralized applications to apply them for kind of decentralized exchanges and how to monetize your websites in a decentralized manner using dApps, how we call them. So what I'm actually going to be talking about is a really broad subject, because this was originally going to be a Ethereum development meetup, and we actually understood that a lot of people who came here are not software developers. You are either business people, lawyers, or students who are interested in the technology, and I don't think it would be right to deny you the right to learn about this fascinating new technology that I'm definitely sure will propel many of your industries into the 21st century. So we're going to begin by introducing the concept of money, and it might seem trivial at first to talk about money. We all use money, and but there are a couple of important aspects of money that we kind of miss when we're talking about it. Because when you use a euro, you don't really think about what is this euro, how was it made, how do we use it. So the best introduction for me would be to kind of go back and think about the history of money. And the way money has evolved was, first it was a form of in-your-mind ledger. So I would borrow you a fish, you would have to return me a fish. I would borrow you a pound of rice, you would have to return me a pound of rice. And this worked fine for some 50,000 years, I think, when people lived in small tribes and they were able to remember, okay, this guy gave me a fish, this guy did a service for me, I owe this guy that, and everyone knew how that went. But when our society started being more kind of sedentary, and when we started building communities that grew over 150, 200, 300,000 people, it became literally impossible to memorize who is the owner of what and how do we track the value, how much someone has. So the first early attempts of money were the ready available things that everyone needed and that were scarce in demand. So you'll see here it says that money has to have certain traits. And without these traits, money is generally worthless. So these traits are authenticity, divisibility, scarcity, and portability. The first example of money would be salt. This was an early example because people need salt to live, and they used to dig salt, but then someday they realized, okay, nobody has too much salt because you can't create salt out of thin air. So salt is scarce. Salt is easily portable. I can give you a gram of salt. I can give you a gram of salt a mile away if I bring it with me. Salt is divisible because I can also give you a kilo of salt. I don't have to give you a gram. So salt actually, and it's authentical in a way that you can't counterfeit salt. You can't, I mean, it's super easy to test, is this salt? Yeah, it's salt. And if it's not salt, you don't accept it. So these are, for the past tens of thousands of years, these are the traits that our money always had to have. This evolution went kind of logically from salt, then people realized, okay, maybe we can do something better. The first evolution was kind of stones. There is a famous example of some islanders using huge stone blocks as money and then remembering who owes what to whom. The one which most of you are already familiar with is precious metals. People throughout history have used silver, gold, copper, whatever, to trade with them. So for a long, long time, actually, in the European history, all the way up until the maybe somewhere 16th or 17th century, we actually used precious metals for the majority of our trading. Some cultures, specifically in the Indian and Chinese, kind of Eastern Asia part of the world, they used paper money much earlier on, but they also had it tethered to precious metals. And we also had that until somewhere in the 20th century, where our money was actually needed to be returned to precious metals. Then we actually evolved to digital money. And digital money was nothing more than a representation of our existing currencies. So you had euros, you had dollars, but you just didn't print them on a money, you wrote them somewhere on a computer. So beyond this part, the digital money wasn't really that much different from our paper currency. Since paper currencies are also super portable, this was just a little bit more portable. And somewhere in the 1990s, a group of people in the crypto hacking world actually started talking about, okay, this is digital money, but it really doesn't do that much more than that other technologies couldn't do. So how can we make it better? And the big thing they were always talking about in those circles was making money decentralized. They wanted to make it so that you can send money to that person and that person can send money to that person, and that you don't have to have a third person monitoring the ledger. And there were a couple of ideas going on. There was the Bcash idea, there was the digital gold idea, and if you look at the history of the blockchain, you will notice that the entire community that actually developed blockchain, it wasn't just Satoshi Nakamoto. He just finalized the final straw on the blockchain white paper. The entire community was actually involved in this for over 20 years before blockchain actually became a real thing. And then in 2009, a revolution came. A magical thing called proof of work. So we had this digital money supply which was centralized, and we had this money supply which was decentralized but not secure. So on the one hand you had the banks, on the other hand you had the crypto hackers, but nobody had both. And then they thought of proof of work. What if we could make computers solve very, very difficult computational problems? And the only way to verify transactions on a network would be to solve those difficult computational problems. Then we could make sure that nobody could falsify transactions unless they have the vast majority of the computing power of the network. And this is where the kind of mathematical and behavioral economics part comes in, because people are driven by incentives. We are driven by what can I do to make my life better or my immediate surroundings' life better. And if we have an incentive to keep the network secure, the network will be secure. If we don't have that, we don't have a network. And by doing proof of work, you solved actually nothing, because you don't incentivize people to do proof of work. So how do you solve this problem? You actually go and give rewards to people doing proof of work. When somebody solves the difficult computational problem, they are actually awarded new coins created from thin air. This actually has an inflationary purpose on the blockchain itself, which is super compatible with our current economic models. And it allows us to incentivize people to actually spend the money and invest and build mining rigs and secure our network. Without that, it wouldn't be useless, but it would be significantly less useful. So, as most of you know, if you're here, I'm assuming you know that the first example of a cryptocurrency was Bitcoin. And the Bitcoin is just an example of cryptocurrency, which is just an example of an application of blockchain. It's important not to confuse blockchains and cryptocurrencies. Cryptocurrencies are currencies implemented on a blockchain. But you can have something else implemented on a blockchain. You can have a system for tracking people's names globally through the, let's say you have a system for tracking who owns a house, who owns what house. You can implement it on a blockchain. And it's not a currency. It's not a cryptocurrency because it's not a currency, but it's implemented on a blockchain. And it leverages the property of the blockchain that it's free, permissionless ledger where you don't have to trust anyone to do the things you want to do. So blockchain is open. You can see all the cryptocurrency and other stuff which is issued on it, but you don't have to trust the third party that those things that are issued are actually valid. And this, which we'll see later in our presentation, opens a whole new space of possibilities for developing not only currencies, but plenty of other implementations which are, in my opinion, going to transform the way we do business, law, and many other things in our day-to-day lives, starting from this year onwards. And the big example of this is smart contracts, but we'll get to it on a slide which discusses Ethereum. So, as I said, Bitcoin is the first cryptocurrency, one use case of a blockchain. But what things we discussed that a currency must have? Currency must be scarce. Bitcoin is scarce. There will never be more than 21 million Bitcoins. No matter, unless you hard fork it, but we'll not get into that. There will never be more than 21 million Bitcoins. They are created. Every 10 minutes, new Bitcoins are created, and they are awarded to the miners for securing the network. But this will not continue indefinitely. The award which miners get halves every 2100,000 blocks. And one day, this award will actually be zero. And this is actually projected to happen in 2140. And after that, I don't think anybody here needs to worry about that very much. But we got to worry about our grandchildren, how they'll use Bitcoin, because I do think they'll use blockchain. And after that, the network will be secured and awarded by something called transaction fees. And without getting much into it, every time you make a transaction of Bitcoin, you need to pay a certain fee, so your transaction gets included in the next block and actually passes through. Think of it in a way as paying a fee to a bank to clear your transaction. And after 2140, the assumption is that Bitcoin will be so widespread that the fees will actually create a huge amount of money and be very, very useful for the miners securing the network. So these are the traits which make Bitcoin a great cryptocurrency. But as I said, it's not the only application of a blockchain. And I'm going to repeat this a lot of times because I think if you're going to take one thing from this, is that blockchain is not just a cryptocurrency. We actually call this the Ethereum blockchain development meetup because you as a programmer or as a business person can innovate and develop on a blockchain. You are able to create whatever you want using the blockchain technology. Okay, so just to get a little bit into the technical details, the way blockchains work is by leveraging something called asymmetric. This is a typo, actually. This is asymmetric cryptography, which means that you have a pair of keys. You have a private and a public key. You can always derive a public key from a private key, but you can never, and I mean never, derive a private key from a public key. And the big thing about this is that you are able to sign and verify transactions. So if you own your private key, you are able to send money to somebody. But if they don't have your private key, they can't send your money to anyone else. But you can give them your public key, and they will be able to verify that your transaction is valid and that you did not lie to anyone. So public keys are used to verify the transactions made by private keys. But only the person holding the private key is able to make a transaction, actually. And in other forms of blockchain, such as Ethereum, there are smart contracts which are controlled by certain accounts, and the control aspect of those accounts is actually leveraged through the use of private keys. And yeah, actually, the big thing people ask me sometimes is, how do I create a Bitcoin account? Well, actually, you don't. You don't create it in a way that you have to run some software to make your account. All accounts are already available. All accounts are already made. So there is a huge space of accounts. When we're, some of us who work on blockchains, when we're developing blockchain applications, we are able to make tens of thousands or hundreds of thousands accounts each day. And it doesn't really matter, because there is so much possible accounts on Bitcoin that if each and every one of us made 100 million accounts for 100 trillion years, we couldn't exhaust the account space. So what do you do to create an account? You actually just write on a piece of paper or on a computer or wherever, you generate your private key. And this can be really, depending on a blockchain, there are certain rules how your private key should be formatted, but it's a really free form kind of thing. The big important thing is that you shouldn't actually write your name as your private key, because remember, anyone can derive your public key from your private key, and everyone who has your private key can use your funds. So try to make your private key as secret as possible. Kind of when you're making your accounts, if you get interested in Bitcoin and don't know how to make accounts, when you're making your accounts, try and have somebody else make a private key for you. There are great services out there. Inform yourself, first and foremost, because there are many scammers out there also. Inform yourselves and have somebody else create a random key for you. So the more obvious patterns you have in your key, the weaker you are. So if you have your name, your birth date, or anything similar to that, you have a very weak key, and if you're using it right now, change it. Somebody will steal your funds. There are very much cases of theft and fraud for people who are not careful. If you are careful, if you set up your accounts properly, it is difficult to impossible to steal your funds. But if you are not careful, if you go into this kind of, okay, I'm gonna invest, I'm gonna make an account, I'm gonna store it on my internet connected PC. Yeah, okay, if you're storing $500, but if you're storing $50,000, make sure to educate yourself and never in a million years give your private key to anyone. Okay, so now that you got that memorized, remember that you also need to watch out for multiple chains. Some cryptocurrencies, as of late, have developed counterparts. The most example of it being the Bitcoin Core and Bitcoin Cash chains. You will be able to send transactions and kind of modify stuff between chains, so be wary of that and educate yourself about that. Okay, next thing, and the big thing, the most important thing why we're here. It's kind of a blockchain 2.0. If you can use Bitcoin to send transactions, you can use Ethereum to send transactions and do infinitely many more things. So think of, and this really is the cheesiest kind of blockchain analogy that absolutely everyone uses, but I think it's very fitting, and that's why everyone uses it. Bitcoin's a calculator, Ethereum's a computer. What does a calculator do? Press numbers, it can add, multiply, divide, but can you run Pac-Man on a calculator? No, you can't, because it's not programmable. Well, Ethereum is programmable. It has a virtual machine for the developers among you, and you are able to program your own applications on top of the Ethereum blockchain. And later today, on a workshop, which is the final presentation of the day, we will show you how to implement a domain name system, something that took common, kind of general programming developers thousands of hours and iterations to develop. You will be able to develop almost the same thing in 50 lines of code, and it will be almost equally as secure, because you are leveraging the blockchain to be your friend, to kind of secure all of your transactions. So when we're talking about a programmable blockchain, there are a couple of problems we need to deal with. And the first problem is infinite loops. Okay, so since Ethereum is a Turing complete blockchain, and in programming terms, it means that any program you can conceive of is able to be programmed on an Ethereum blockchain. And if we have an Turing complete blockchain, what can we do? We can just write, okay, repeat this piece of code forever. And what will happen? Your code will get deployed to thousands of computers all around the world, and they're gonna run it. And when they run it, they will kind of nuke their processors, and they will not work because you actually ran an infinite loop on thousands of computers all around the world. Well, in order to prevent this, the folks at Ethereum came up with a super smart idea called gas. And gas is a really cool thing which actually charges you a price for every computational operation you do on a blockchain. So let's say I want to add 2 numbers on a blockchain. I have to pay to add those 2 numbers. Let's say I want to do something else. I have to pay. And remember, these are generally minuscule amounts of money. They are very, very small amounts of money. But what they effectively do is if you want to run an infinite loop, go ahead, write an infinite loop. You send, and every time you run your transaction, you set the maximum amount of money you're willing to spend on that transaction. And you run your infinite loop, it goes through 10,000 iterations, and it spends all of your gas. You are now $50 poorer, the miners are $50 richer, and you actually accomplished nothing because your loop had to stop because it ran out of gas. So this is the way we solve the infinite loop problem on an Ethereum blockchain. And currently, one of the most used purpose of the Ethereum blockchain is the issuance of custom tokens. So as we have the Bitcoin blockchain for validating transactions, we are able to, on an Ethereum blockchain, we are able to issue our own type of token. So let's say I want to make a Zagreb coin. And I want to say there are 1 trillion Zagreb coins in existence, and they are all owned by me. And I can give it to you. I can write a piece of code on an Ethereum blockchain, which will create those, billion tokens, and they will issue all of those to my private key. I will be the owner of those tokens. And if you give me your public key, I am able to send you my custom tokens. So this is actually the revolution of the Ethereum blockchain over the Bitcoin blockchain. You are able to create your own store of value, and you don't really have to be dependent on the outside forces of Bitcoin or even Ether. Ether is just used as fuel to pay for gas, and the gas price is independent of the Ether price. So you are actually not locked in to a system. You are able to create your own code. And here I'm actually just kind of iterating, and I really encourage you, because this is a very broad topic, I encourage you to Google all these things if you are really interested. But these are some of the most common implementations of the custom tokens right now. So you have the ICO, which is an initial coin offering, which is when a company has a finite token, which they can use as a integral part of their application. So let's say we have the Golem project, which has the GNT, the Golem token, and they use it to pay for computational power. So you can render a 3D model on your computer, and somebody is able to pay you with Golem. What it does is it creates scarcity, it creates usability, which gives those tokens value. So Golem actually now has a value, and it's tradable on a market, just the same way Ether is tradable and just the same way Bitcoin is tradable. So they made an initial coin offering where they sold a certain amount of those tokens to do an early crowdfunding, to do an early funding, and actually have an innovative way of gathering money in the early stages of the company. The next big example is the DAO, the Decentralized Autonomous Organization. And a decentralized autonomous organization can be a credit union, it can be, let's say, a savings union, it can be a landlord association, it can be really much anything. What a decentralized autonomous organization has is a list of members and the list of voting rights of each member, and each member is able to vote on proposals. Let's say, okay, we're a credit union, we're saying, are we gonna issue a loan to this person? And everyone votes, and okay, I'm voting this, you're voting that, and then in that way the decentralized autonomous organization is able to create kind of contractual obligations which are confined to code and really don't depend on the externalities of the real world. And actually, the Ethereum blockchain had a couple of hacks done to their early DAOs, but I wouldn't be discouraged by that because the technology just keeps getting better and better and better. And I think we're going to see a lot of use cases for decentralized organizations in the future, especially with maybe NGOs or nonprofit organizations and credit unions and share issuers. There is actually a whole new universe of applications which can be decentralized and not centralized. And one really cool thing that I think blockchain enables us is to create our own sovereign identity on a blockchain. So we are actually able to represent ourselves and our purchases, our loans, our communication with people on a blockchain, and in that way generate a reputation. Let's say a credit score which is independent of the crediting agencies which we use today. So in Croatia currently you will have your HROK score, which is actually kind of your credit score, which enables will you get a loan, will you not get a loan, and what it actually represents is how much do the credit issuers trust you. And this trust must be kind of implemented through a proprietary algorithm that you can't see, that you don't know how it works. You just know you come into a bank and you can get a loan. Well, here, this entire process can be independent, fully open for you to review, for you to process, and it doesn't require you to trust another person to do so. And of course, what I mentioned now is just one of the implementations. I think there's thousands of implementations right now, and throughout the years there will just be more and more creative people who think of new ways how to exploit the open ledger, which is the blockchain, for their kind of companies and their activities. No actual presentation will be complete without this topic, and this is anonymous cryptocurrencies. And maybe people told you that Bitcoin is anonymous or that Ethereum is anonymous. Well, they're not. They're open ledgers. And the key word here is open. Everyone can see how much money or funds or tokens or smart contracts there is on a single account. Everyone can see which account sent what to what other account. So they're completely transparent. And this is not something that actually a lot of people who are using the cryptocurrencies imagined in the beginning. Because for most of you, the only way to get into cryptocurrencies is through an exchange. And when you're going through an exchange, you have to leave some piece of personally identifiable information, such as your email, your first name, last name, credit card, or whatever. And one day, let's say you are caught with your money and somebody wants to trace back what you did with your money. They are easily able to trace back your money to that exchange. And then if they're a powerful entity, they are able to pressure the exchange into giving your personal information. So this is kind of against the common rules of the early blockchain of the early blockchain crypto hackers and the cypherpunks, they call themselves. They actually wanted a free world where we could exchange goods without unnecessary oversight. Something akin to me giving you a piece of cash. When I give you cash, it's really, really hard to tell that I gave you the cash and that you are actually now the owner of the cash if you don't decide to disclose that information with the outside world. Well, now we can actually do that on a blockchain. Thanks to a revolutionary technology, and this, for the kind of geeky of you, this is implemented via ring signatures and kind of the multiple inputs, single output kind of thing. But all we need to know actually is that's a revolutionary technology which enables us to hide completely how much funds does a certain account own, who is sending funds to whom, who is receiving funds, the kind of capacity of the network, the amounts which are being sent are all secret. But every single node is able to verify that all those transactions are valid. And the ZK here stands for zero knowledge. And it's a kind of an area of mathematics and computer science which is called the zero knowledge proofs. What it actually means is you have zero knowledge of what actually happened, but you are able to prove that that thing actually happened. It kind of sounds absurd when you say it, but it does work, and some of the best implementations of these types of zero knowledge proofs are Monero, Zcash, Dash, and many others. So if you're into anonymity for whatever reason, you should really take a look at private and anonymous cryptocurrencies. And in the final stage, which I'm not really a fan of this, but I should really mention it. If you're working with a large corporate kind of entity and they are kind of skeptical of the blockchain world, well, you're always able to run your own blockchain. Nothing really prevents you from copying the code and running your own blockchain, issuing your own tokens on your own network with your own nodes. You will lose on the security of the network, because remember, the security of the blockchain network actually grows with the number of participants. So if you have a large number of participants, your network is very secure. If you have a small amount of participants, your network is not very secure. But certain corporations, they have a desire for control, safety. They don't want to expose themselves to the dangers of the public blockchain, or they don't want to be associated with kind of all the media connotations of the blockchains, so they decide to run their own blockchains. Best examples of this are IBM, Microsoft, JP Morgan, Tesla, Intel, and plenty others. I think there are over 500 members in the Ethereum Enterprise Alliance. Most of them run their own blockchains. Some of them work on the public blockchain, but they're mostly big corporations which decide to work on the private blockchain. And this would be it from me. How are we standing with time? Well, we're actually just in time, and we have some 10 minutes for any questions you might have. I'm gonna try to answer them the best I know. So let's say we're gonna have 10 questions, because we are really constrained on time, and it's first come, first serve. Anyone? Excellent. Okay, so last time we did this, we had a 1-hour Q&A session, and it kind of dragged on. Oh, question. Yeah, actually, they are equally secure as the. She asked. I said that they are less secure. The private forks are less secure, and she's wondering if that's only a consequence of the hashing power, which is true. It's actually just a consequence of the hashing power. There are less people who are securing the network, and the network has to be less secure. Okay, yeah, I think we could have had this presentation run for 3 hours. We could have mentioned proof of stake. Proof of stake is a new kind of validation technique which can replace proof of work. It's a process where everyone stakes their already existing currency, and if they behave in a way that the network doesn't benefit from, their stake becomes burned, and they have an incentive to secure the network that way. But I think that that's currently the much less used approach, even though Ethereum is going to that approach. So decided not to put it in the presentation. It would be maybe unnecessarily complicated.
Hashing power, I would like to comment. The hashing power thing, it's there just to validate that the transaction block really happened as it happened.
Yes.
Any other validation technique would really do. So when you have, for example, JP Morgan and stuff developing their internal stuff, such as Settlecoin,
yeah,
their trust is based on the fact that they all have contracts between each other.
Yeah, their trust is based on the fact that they have a contract between each other, but they are not. Yeah, but in that way, this is not much more secure than a well-implemented database. So, of course, they know JP Morgan wouldn't do anything without trusting anyone. But the very fact that they are running and controlling all the nodes, well, they're actually running a centralized system. They might leverage some traits of the blockchain, but in essence, they are not profiting very much from the blockchain technology. Is that it? Oh. Može na hrvatskom ako.
Black and gray economy.
Okay.
So do you see in the future that maybe state regulatory bodies have control? Because
yeah. Of course, but the big thing is, I think as a country, nobody's asking you to. Nobody's asking for permission. And since it's a decentralized system, you don't really have the power to come in with a warrant to a server room and close the network. You can't. Monero doesn't really have a person who is running the Monero servers, and you can't stop it. It's very hard. You can make it illegal and make it harder for people to use, but if people need to use it, people will use it. So I think the best regulatory approach for our regulatory bodies would be just to join the revolution, not kind of push back. And I think some of them will push back, but those who push back will probably be not destroyed in the process, but significantly weakened.
yeah. I'm a country subsidizing building of apartments or something like that.
Okay.
And someone wants to buy them with
Okay. Well, you don't have to accept it.
Yeah. So do you see that that may be one point of failure for anonymous?
Well, actually, what we're entering here is what the economists kind of call the free market of money. So most of us, for the entirety of our lives, have known monopolized money issued by the government. But in a sense, anonymous cryptocurrencies will probably never be used by large countries and regulatory bodies, but they will still be able to be used. Even if only 100,000 people in the world use them, this currency will still exist and have value. It doesn't depend on widespread usage to have some value. So it can always have some value as long as people are willing to use it. Anyone else? Okay.
Zero knowledge blockchains. As far as I understand, the transactions as well as the parameters are always public in a blockchain network. For example, Ethereum makes it transparent, Bitcoin makes it transparent.
Yeah.
Are you saying that there is a method to make the transactions along with its parameters completely anonymous?
Okay, so he asked if the main trait of the blockchains, as he knows them, is the publicly open transactions. So on Bitcoin, Ethereum, all transactions are publicly available. How is it on private networks that we have kind of the closed transactions? Well, that's the big thing of the zero knowledge proofs. They're kind of moving the paradigm. You are able to have a distributed ledger, but it's a secret ledger. And the ledger, only you can know how much money you own, but the entire network can detect if you sent an invalid transaction. So they can verify the validity or invalidity of the transactions, but they do not know how much is being sent or from who to whom, because everything is stored encrypted. Yes?
Also, nothing prevents you from creating a separate account for every transaction, and then you basically achieve full anonymity.
Yes, but on a public blockchain, this is also not full anonymity because, as I said, if you're, and there is a lot of analytics software being developed, if you're really trying to kind of hide yourself, if you're really trying to find somebody doing bad things on a Bitcoin blockchain, you can always trace back the chain of transactions to a person on some exchange somewhere. So yeah, that person's gonna get into a lot of trouble. And people are already doing it. This is not some kind of magic voodoo which police will use in 50 years. It's already being used to track down various types of criminals. So yes, if you want full anonymity, don't use Bitcoin or Ethereum or any kind of open blockchain. If you want smart contracts, use Ethereum. If you want a store of value, let's say, use Bitcoin. So it's your choice, actually. It's a whole new market. It's going to have a lot of new implementations, and it's on you to choose the best implementation for yourself. And this would be the all of questions. Thank you very much for coming. And in kind of, let's say, 10 minutes, we're going to have another presentation. So thank you all. live stream. Neće ništa pojačavati, ali tako priča glasno.
Probat ću.
Vjerujem mi, priča glasno. Čekaj, sam imao neku najavu za televiziju.
Da.
Šta da radiš? Okay, everyone. We're gonna be having a second presentation of our meetup. It's gonna be Marin here talking about the block stack and the peer-to-peer exchanges on the API of the blockchain. Marin actually is an active blockchain developer, and he's employed with the Status IM company, as you might know them for their very famous ICO just a couple of short months ago. Also, I'd like to note to everyone that if this discussion is too technical for you, there is an opportunity to follow the live stream and mingle at the bottom floor. Also, we would like for a majority of you to stay as long as possible. We'll be having food coming in some half an hour. So, yeah, of course, the goal is networking, so as many of you stays, it's better for us. Also, one thing I'd like to mention is if you're trying to get informed about Bitcoin, Ethereum, or other blockchain applications in Croatia or in region, you can visit the bilingual English and Croatian site bitfalls.com. They are a great resource, and they are also looking for writers if you're technical and competent enough. So visit the site and give them a call. Now I would like to hand it to my colleague.
Thank you. Okay, so today's topic will be about using the block stack. Basically, it's a developer tool for building decentralized application. Well, this is centralized. And peer-to-peer exchange, basically it's my side project that I started to work with using the Blockstack API. So, short about me, my name is also my name of the company. I find myself a clients, I work with them, I develop the solution for them, and basically the extra money that I got, I invest in some kind of another startup project or something like that. You know, basically most of the companies that I work is in adult, medical, and blockchain industry. So yeah, porn. I mean, it's great. I mean, most of the developers didn't know about that, but adult industry is missing good quality developers. So you know, if you're a good quality developer, you know they are paying extra cash for it. So yeah. So to understand the block stack and the decentralized internet, we need to understand the problem with the centralized internet. So with the centralized internet, we have the problem with mass data breaches. So stolen information, stolen credit cards, identities, and so on. By using the block stack, by using decentralized internet, you have your own data, so own data offline. For also the insecure connections, right now, there are not so many websites that have insecure connections, but most of them had, and you know, some of the people can eyedrop and stole your information. Also, there is a platform lock-in. It's an issue with you know, if you're using the Mac, you cannot use that kind of application. If you're using Android or Apple, and you know, there is some kind of platform lock-in for it. So you know, someone will say that decentralized applications are hard to build because of the complexity for it, the security and scalability, because you need to cover all these three things to have, you know, your own application be secured and scalable. So this is where the Blockstack comes in. Basically, it's an API where you can query some of their services. And you know, right now there is a need for the browser portal. So basically, it's like kind of like a Tor, so you can, you know, access to it and see the decentralized applications. So this is the simple how it works. So basically, your Blockstack application relies on the Blockstack API, and the Blockstack API provides you with the identity, with the storage, and also with the payments. So basically the payments are in cryptocurrencies. You can choose any kind of cryptocurrency to transfer, and you can also store, because you have your own application which is decentralized. You need to store somewhere your data. So basically the Blockstack API provides you an offline storage for the users to store the information. So in more complex way, this is how it works. Basically on the storage layer, the user can choose to save the data to Dropbox, to personal drive, to torrent, or any kind of stuff. And there is also the routing layer and virtual chain layer, which means that in the decentralized internet, someone needs to find your application. So basically there is some kind of ID that you register your application on it, and user can easily find it. And also the blockchain layer that is covered by using the cryptocurrencies, the Bitcoin, the Ethereum, and the Zcash. So right now, how much developers are joining in, including me, they have a steady growth. So this is basically the Slack channel that you can join and discuss with other developers. The CEO of the company is there also. They are really helpful. If you have some kind of information to ask, you can ask there, and join the community also. So most popular example of decentralized application is OpenBazaar. So I don't know how much you heard about OpenBazaar, but it has a lot of good quality stuff that you can easily build your own e-commerce site offline. So basically you can easily sell and buy the stuff like a eBay, or decentralized eBay. It gained popularity most on the darknet because of the black market, because it's decentralized, no one controls it. But there are many good cases of using it. So yeah, peer-to-peer exchange. Why I started this, what I'm doing is because many of the newcomers into cryptocurrency ask me about, I want to buy some Bitcoins. I want to buy $10 worth of Bitcoins. What should I do? And it's crazy to ask them to go to the exchange, do the know your customer stuff, scan your passport or any kind of stuff. And this is hard. I want to provide users, newcomers especially, they can easily buy exchange and buy the cryptocurrencies. So problems with with the centralized exchanges is the data breach. Also, we all remember empty GOX when millions of Bitcoins were stolen. The problems also with the users, they don't trust the exchanges because I'm typing their credit card on the exchange, and what if there is a data breach? All the credit card transaction will be stolen. Also, the know your customer, I need to have that to buy some Bitcoins, to buy some Ethereum, and there is also a problem because it's connected to the data breach. So I'm giving that to them. Also, the trust, it's problem. Most of the trust is on the local Bitcoins, on how the trust between the seller and the buyer, and the problem with the different exchange rate. Basically, it's much greater exchange rate than other exchanges. So the solution for this is by using the Blockstack API. I implemented some kind of buyer and seller that are on the network, and they are mining in the background. So why they are mining in the background? This is they are mining because they are providing the location of the buyer and of the seller. Think about Uber for cryptocurrencies. So basically, I want to sell my Bitcoins. I'm connected with a buyer for a fiat currency. We exchange, and that's it. So when there is a block match, when I mine, when there is a block match, that means that the seller, connect to the buyer. We will, go to the physical location or do a credit card transfer. Right now is a physical location. So we will, exchange that money. We will rate ourselves, and that data is stored on the Blockstack API. So there is no, on that application, peer-to-peer exchange. I mean, I don't have a name for it, but I hopefully will do. Every data is stolen, every data is stored offline. So there is no online or any kind of centralized server to save that kind of information. So basically, here is some kind of a demo. You can see here that it's on the decentralized internet. What you can see here are the buyers and sellers, the devices itself that they are, exchanging itself. So basically, if I want to buy, I will press button to buy the cryptocurrency. If I want to sell, I will press to sell, and I will be matched to the seller or a buyer. And if I don't want to buy or sell, I want to be on the network itself, because we need to have a lot of users to use that network to to route the traffic. Basically, I get rewarded because in the backend I'm mining the cryptocurrency itself. So basically, when I'm connected to the buyer, there is no transaction fee for it because I mine that cryptocurrency for them. So this is great because it's new type of investment, I will say, or funding, because it's a proof of work. You can see here my phone, it's mining. I'm mining now Monero because it has this cryptographic that can be used on the CPUs. So it's more better for the phones to mine. I can see here 11 hashes. The PC, normal PC, is 60 hashes. Even my TV can mine. I mean, it's not a one hash, but it's something. And even in the future, you can connect your smart devices on the decentralized internet, and that device can be a exchange router to the peer-to-peer exchange. So when someone asks me, how well, Marin, you need to make money from it, because there is no ads, there is no transaction fees. How do you make your money? So basically, by mining, I collect, let's say 15 million users is the users that are regularly on the local Bitcoins. Let's say that in the middle it's a 50 hash, and each of the users stays 30 minutes on the site itself to find the buyer or seller. It can generate $20,000 around, based on Monero $90. So that number will grow, because if a lot of people will use it, it will grow more than 50 million users. Monero price will rise. We will have much stronger PCs and mobile phones. The hash rate will rise. Maybe 30 minutes is not enough. Maybe will people stay there for hours and hours. So basically, this number is just an example on what you can generate from it. Yeah, basically, that's it. It's a small presentation, and if you want to learn more about the Blockstack and how to use, you can visit the blockstack.org website. Also, this project, this peer-to-peer exchange, it will be open source, so I will put this on my GitHub, so you can so everyone can use it and build their own exchanges, because we need a lot of new. I mean, we need a lot of people to use that exchange, so the exchange can work. And basically, that's it. Thank you. Questions, maybe?
What is the blockchain based on?
It's purely from the scratch. So the Blockstack is doing all the hard work for you. You only use their API to access that. So you don't need to know the complex layer of the blockchain itself. So basically, it's decentralized.
Did I understand correctly that when people are setting up a transaction, the location of those people is public?
Repeat the question for the live stream.
Okay, so he asked if the location is public. Right now, in the testing phase, yes, it's public, but in the future, it will be most likely like a Uber type of exchange. So you will not see the drivers, but when you click to, buy or sell bitcoins, you will be connected like a Uber to that seller or buyer, and you can, connect with them and do the transaction. We can meet up at, some place and do the exchange person in person.
How simple or complicated it would be to create a sub-network based on some kind of interest group or region or something like that? I'm thinking OPGs, for example.
So how complex will it be to build like a OPG kind of application?
Like a peer-to-peer connecting service, for example, that will connect OPGs with clients in the city that would like to buy fresh vegetables. For example, just.
Yeah, basically you have the storage, so basically you can do whatever you are capable of it, because most of the application development is from you need to have the storage, you need to have the payment, and you need to have the identity. So Blockstack itself provides you with identity ID that verifies you that you are that kind of person. And this peer-to-peer exchange, basically, why it's mining, because it's doing that kind of proof of work to kill the bots, to kill the spammers. So you need to do this type of work to prove that you are real human. So yeah, basically it can be possible.
It's only peer-to-peer exchange, because I remember this concept being discussed years ago.
You ask if it's only peer-to-peer exchange.
Implementation of peer-to-peer exchange.
Yeah, it's only implementation of peer-to-peer exchange, but it's more like person-to-person, because right now for example, I want to sell you $10 worth of bitcoins. How we can do that? I mean, you don't trust me, I don't trust you. How do you know that you will not scam me? So basically this is type of the application that will provide like a middleman to prove the identity, to prove the payment, and to prove that you are a real human, and of course the rating itself, that we will not get scammed. So it's basically that kind of idea. But in the future it can be massive, credit card transfers, bank transfers, any kind of other stuff. But right now it's more focused on the small people that they want to start with buying and selling the cryptocurrencies. Yes?
So obviously when one device is mining, that's kind of useless. So you have to pull the hashes somehow. Do you pull them into your own pool, or do you send them to a pool like CoinHive or something like that?
Yeah, basically right now it's on the CoinHive, but in the future I think I will implement it, the own system, because the CoinHive take like 30% of the reward. So it's crazy, but it's type of proof of work to see if that kind of stuff works, and it works, so it's okay. And that's it. Okay. Thank you.
Okay, huge thanks for giving us the presentation. We will have one more presentation and then a really short Solidity workshop, just to get the software developers among you who are interested and kind of giving you the first steps you need to go along. Now, let's see the time. Okay, it's 19:33. We will have the next presentation at 8 p.m. sharp. So be there or be square. See you then. god, evo 6 minuta je prošlo nakon našeg dogovorenog roka, tako da bi ja sad zamolio Nikolu, koji je iskusni blockchain developer koji je u prostoru već duže godine od većine nas i koji je trenutno evo upravo završio jedan trenutno u procesu uspješnog ICO-a, da nam kaže nešto o INS-u i nekim drugim tehnologijama koje je on našao korisne na blockchainu. Evo, za sve vas, to je Nikola i samo molim mikrofon, ovo zlatno ti je.
Test. Malo dalje. Okay. Should I do this in English or Croatian? English?
English, I think we have some people who don't understand.
Yeah, cool. English is fine. So hi. At first, I must apologize. I haven't slept for few days, so the presentation is kind of naked, but we will successfully go through the Ethereum name service, hopefully, and introduce ourselves a little bit about the technology. My name is Nikola Jokic. I'm the CTO of Digital Assets Powerplay, which is currently the most crowdfunded project in Croatian history. We are currently running an ICO with $2.5 million of investment as of today. We have 20 more hours to go, so if somebody wants to grab some DPP tokens, what, louder?
No.
Ah, okay. You have 20 hours to go if you want to contribute, but it's a great fucking success for a Croatian ICO. Thank you. So that was the reason I didn't get much sleep, and that's the reason why the presentation is not up to the par as I would like it to be. So Ethereum name service. Does anybody know what Ethereum name service is? One? Nobody. Huh? Yeah? So you didn't do your homework before the presentation. Okay, so who knows what's DNS? Ah, okay. The idea is similar. So if you understand DNS, you will probably understand ENS, but it's implemented in smart contracts. So it works on the Ethereum blockchain. A bit of my history. We were incorporated in 2015, but we are in the industry for a year or two longer. This is three of my partnering founders and me. We have over 30 investors from Croatia, UK, and all around the world. We do algorithmic trading for years now, so we trade with cryptocurrencies across the exchanges, but that's not the point of the talk today. And when we started, it was easy. Now we have thousands of new crypto assets daily. With every new ICO, you have a new tradable pair, and it's becoming a hard problem to track what's happening across the markets. With Digital Assets Powerplay, we used smart contracts to enable more efficient and distributed economy when algo trading is the topic. So we are kind of a parallel solution. We are not all in blockchain. We think the current technology is not so mature to be totally on smart contracts, but we are developing some kind of parallel solution where algorithms are run on the cloud, but the financial management is run on the smart contracts. Did anybody wrote a smart contract here in their life? 2, 3, 4. Yes, nice. So I'll use this opportunity. I see some women in the audience. Can I see what? Hands up, please. 1, 2, 3, 4. Yeah, nice. I have one message for you. This is a really young industry. We don't have any establishment here. If you go to our website, you will see only males, and I really don't like that. So women, please, there is no establishment in this industry. Everybody is learning. We will learn for a few years longer. So please, now is the time to go and enter the industry. So don't allow this bunch of males to run it, because you started development. First developer, software developers, first software language, all women. Let's fix that shit right now. Yeah, it's an opportunity, you know. You have currently in the IT, you have the establishment, and you need to fight against it. Now we are creating it. You know, there is no official organization in Croatia working with blockchains and smart contracts, except, which is interesting, we have the ICO TC 307. It's a technical committee focused on smart contracts and blockchain, the standardization of smart contracts and blockchains, and Croatian, how do you translate it? Hrvatski zavod za normative. Standardization office started the technical committee. It's a global initiative, but we have a local body. I'm a member of it, but only currently. I haven't consumed my membership because I haven't been on a meeting yet. But I'll try to help as much as I can with my hands-on experience. I'm not so good in standardizations, but I'm good in writing smart contracts. So I'll do my best to help them see what's actually happening in there. So contact them and maybe organize yourselves. Who knows? We're in some kind of organization. We are here. There's a bunch of us. Let's make this happen. But let's focus on technology and use case. We are currently developing protocols. Ethereum, Bitcoin, all these things are basically protocols, allowing us to have a foundation for applications. The next wave of development will actually be applications. We will just start to see some kind of useful application. It's happening right now. Ethereum name service is one of the protocols that will help us make it more easy to use, because now you need to think about these things if you have your own account. On Bitcoin, it's similar format, bunch of random numbers and letters, and it's hard to follow this. You know, if I move this to a 3, you wouldn't notice that, and your money is gone. You know, it's hard to transfer money safely. I need to take care of this. Either you copy paste, or you read this 10 times, or you like focus on the beginning and the end. But it's easy to fuck shit up if you lose. You know, if you lose one Ethereum, it's a shitload of money. As you can see, I like to swear. I'm from Balkans. If you don't mind, the door is over there. So what's much easier is to have something like this. It's human readable. It's easy to see some phishing attempt. So if I replace this with a 0 and try to steal your money, it will be much easier to see a 0 there than a 0 and the O up there. But to have this address represented as this domain, it's you need some kind of a smart contract to do the resolvement. So when I type this in, so some kind of system must know that this is the resource that it points to. The Ethereum name service allows for this kind of thing. Not just the addresses, but also some kind of content uploaded, even different resolvers. You can even write your own resolver. So you maybe have your own, let's see some kind of fun example. You have your own bar, and you have a list of beer, and you write up your own resolver. When somebody writes beer, my bar.eth, it resolves to that resource of ID of that beer. So you're not limited to addresses, it's up to your imagination. So the goal of the domain names is to provide stable human readable identifiers that can be used to specify network resources. I'm going to read a bit because I haven't prepared for this, but what's important to see when you, okay, let's do this. Who doesn't know what DNS is? When you type in a browser www.google.com, how the computer, the internet knows to which resource to load, how it knows to load the content of google.com. What it does is your request for google.com goes to a DNS server. DNS server looks in his book and look, okay, google.com, this is the IP address of the server that is paired with google.com. It, let's say, redirects you to that IP address, and the computer behind that IP address serves you the content of the google.com address. Similar thing here, but the resolvement is not done on the DNS servers, which are also distributed and also in the cloud, if you say so, but they are not self-enforceable. If 7 guys that holds the DNS keys decide to crash things all the way, it will basically happen. This is a bit more secure and better implementation, although it is limited to the Ethereum network. So similar thing is happening with the ENS. There are 3 smart contracts that are required to ENS to work. the registrars, the ENS registry, and the resolvers. The registrars is a contract where you reserve or buy your domain. We'll go through the purchase process a bit later. The registry is actually the list of the domains, and the what's the name of the dot? The TLD, is this called TLD? If I'm not sure in the old school way. Currently we have only .eth, no .hr domain. What I did is I forked the ENS registry and deployed, replaced the ETH with .hr and deployed it to the Robston test network just to play a bit with it. And I was intending to deploy it to the main network, but actually I realized it would be a wrong thing to do, because we shouldn't have a parallel implementation. What we should have is work with the guys behind the .eth to have our own first .hr domain on the Ethereum network. No country has it, so we have a chance to be the first with the .eth. We should contact those guys and say, okay, we want this. Current implementation of the ENS is still a test, let's say, period. Current implementation will last for, I think, next 2 years. After that, we will probably redeploy the contracts and basically do a better way of domain registration. But as is, it is pretty useful technology that we used in our ICO. And the resolvers are basically the smart contracts that will resolve from the wallet.eth to a resource that you require. There are public resolvers that you can use without deploying anything, but you can write your own and say to the registry, okay, listen to my resolver when somebody requests my domain. You can also do subdomains. We did that for the ICO. Sorry. Yes, we used ico.dapowerplay.eth for our crowd sale. So when you want to contribute to our contract, smart contract that is minting the tokens and taking care of the whole process, to be honest, and even out of my control, you don't need to remember this. This is actually the address of our crowd sale contract. You need to just remember this, and this is, I think, much more better than the thing upstairs. The registry contract is the heart of the ENS. There is only one, and with my deployment of the .hr, it would be 2, so we wouldn't be the good guys. So I decided against that. But I can share you the contract on the Robston test network, so you can play a bit. The Robston Ethereum is basically free. There are a bunch of faucets that you can get some ENS, some Ethereum, test Ethereum, and play with a bit. Does anybody know what Swarm in the Ethereum network is? You know, can you tell us a bit about Swarm?
Yes, Swarm is a decentral. Oh, okay. Yep, you want me to go and tell?
Yeah, why not? Because I can do it, but you can do it too.
Yeah, I guess we can do this together. Come on.
Yes.
Yeah. One sentence you, one sentence me, huh?
Okay.
Okay. Swarm is a decentralized file serving service built on the Ethereum network.
Yeah, it works nicely with the Ethereum network, but it's not required the Ethereum network to run. So you can run it by itself, but it's better to have it, because what's the problem with any decentralized distributed file system? You upload the file and it's around everybody's computer, but why would you waste your hard disk space to keep my file? You know, it tends to lose. That's why the Swarm developed some kind of incentive system to reward you if you are keeping some files in it, and it's rewarded by it.
I'll just say that the Swarm has a bzzw// and I'll leave the next to you.
Thank you. Yeah, there it's BZZ protocol, but there are BZZR and BZZ something else depending on what do you want to require. So you type in your browser BZZ double how do you call it, semicolon / and some kind of long string, and you get served the some file, and we can maybe we can test this out. Is this on? Do I have internet on this?
Yeah, we have internet.
Can I?
I don't think I don't have Mist or anything.
No, you don't need it. Let's go through the Swarm gateways.
Oh, sure thing.
Swarm
You
gateway.
put a slash, not a dot.
Let's look at this gate. Swarm. No, the
No,
line.
okay, it's an English keyboard.
Yeah. No, it's not the dot. It's the dash.
Dash. Oh.
Yeah.
Ah, come on.
Yeah, I'll do it.
Okay, so you're a Croatian keyboard?
Gateway. I use something
I can
both.
change the keyboard.
Gateways dot. I think net slash.
Slash, oh, okay.
Slash
Yeah,
bzz two
you need
Okay.
a, what,
the yeah
your program.
yeah pair programming.
Yeah,
Yeah, we
what-
need the rubber ducky here and also
okay.
the semicolon.
We usually do a mind interface.
What?
I guess usually do a mind interface.
Yeah.
Mind interface. The
Okay, yeah.
yeah.
So you did a semicolon, come on.
No, the says slash
What do you need a slash?
slash da power eth and slash.
Slash?
Yeah, let's try this. So Swarm Gateways is a gateway to the Swarm network. If this loads, it's always kind of full of hiccups, so sometimes it doesn't work. But it's kind of it allows you to interact with the Swarm
I
network.
think you're gonna kill your presentation. Oh no, you're gonna kill the other.
Okay. The other option is to install the whole software locally and be part of the node in the network, but this allows us to maybe it doesn't load.
No, not really.
Yeah, just remove the
Manifest not found.
just remove the go with just the Swarm gateways without the power play. Yes, thank you. So it doesn't look like much, but this content was not served from some server. It was served from thousands of computers running on the Swarm network, and basically we didn't communicate with some server to get the content to us. It was collected across the computers and served to us. We just use the gateway. If we have installed the Swarm locally, it would be directly on our computer, which is pretty advanced, although it doesn't look like that because it's a bunch of letters on your screen. But it's basically when it was first internet, some content showed up at your computer and it was wow. But this is wow because we didn't need normal internet. This was done totally peer-to-peer network. So similar to torrents. Anybody uses torrents? Nobody uses torrents. Okay.
I think it's the right one.
Yes. Okay. Then the F11. What?
No, just go to the present, but don't click present. Okay, the presenter view.
Okay.
Okay, now.
I need a.
Clean that.
Okay.
No, not that one.
Okay.
Yeah, okay, there's an explanation for this. We got a live stream going and we don't want to just here. I'm gonna be done any second now. You could do present. Okay.
Okay. So what's interesting about ETH domains is the way that you purchase them. So one question is, if it's totally distributed system, to whom the money should go? Who should receive money when you buy a domain? And we need some kind of system so we have some fair distribution of the domains between us. So the guys were hard thinking for months and days, how should we solve this problem? Because it's a social problem. It's not just technical problem. It's not about the money. It's basically about the social system. And that is something that you will do if you decide to go to the blockchain industry. You will design new social structures. You have tools to create things like that. And that's the future. How to use the blockchain technology to enable people to organize themselves in some kind of new social structures with a value transfer between them using Ethereum or other cryptocurrencies. So who knows what's Vickery auction? It's an old concept. It's nothing new. Nobody? So the Vickery auction is the most fair auction process that we have came as a humanity. It is basically a system that allows to be the most fair possible. It has 3 phases. In the first phase, we have a bidding period. Let's say you want to register a domain, coca-cola.eth. At first, You're the first guy that thought, okay, we should buy a Coca-Cola, and you open an auction. You go to the smart contract, you call a function open auction, you type in coca-cola.eth with some other parameters, and you basically open an auction. It's open to everybody in the world. What's happening then? There is the bidding period. The minimum price that you can put in is 0.01 ETH, but here's the catch. All the bids are private, so nobody knows how many people gave money to buy that domain. It's hidden. So I maybe think coca-cola.eth is 1 Ethereum. Some guy in the audience thinks maybe it's 2, but I really don't know who said what price. In those 3 days, I can only guess who is ready to give so much money for that domain. So during these 3 days, people are sending their own bids. You cannot read from the smart contract who sent who, what money, and basically this ensures that you will give that amount of money that it's actually worth to you, because you cannot compete with anybody. It's not that guy said 1, so I'll said 1.1. You are thinking by yourselves, okay, I'm thinking maybe 1, but the other guy maybe thinks 2, so I'll give 2.1, and the other guy is in the same position, and it's an interesting concept. In those 3 days, anybody can bid on the domain. And when those 3 days are over, there is the reveal period. In the reveal period, people are revealing their own bids. So in those 2 days, 48 hours, I can reveal my bid, and then everybody knows that I bidded 1 Ethereum to that domain. The other guy that bid 2 reveals 2, and he said, yes, I got the domain, I got 2, but in this period, no new bids are allowed. So bidding period is only when it's totally private and hidden. And at the end of that 48 hours, the highest price that maybe was revealed is 2 Ethereum, and the second highest price is 1 Ethereum. The guy that won the auction pays for the second highest price. So even though he bid 2 Ethereum, he's paying the price of the second highest bid, the 1 Ethereum, and the 1 Ethereum is returned to him. If you don't reveal the auction in this period, you lose your money. So you are forced to reveal even though you're the smallest bid in the pool. And this basically ensures that it's fair. Nobody knows who bid who, but in the reveal period you basically have it all on the page. I think the highest amount of money for .eth domain is, don't get me wrong, but I think $500,000 or something like that. $700,000. Yeah, depending on the exchange rate. But yeah, people are buying the domains. One thing to bear in mind, currently we cannot, it is disallowed by the contract to register a domain shorter than 7 characters. So no domains are registered as ens.eth, only 7 characters or longer. This the motivation behind this decision is we currently don't know is this the best way to do it, so let's reserve the domains for future generations then which are smarter. So probably in 2 or 3 years, once we get all the hiccups sorted out in the ENS, the shorter domain names will be allowed for the registration. But here's the secret for you: if you go read the contract, the ENS registry, it doesn't forbid registering the longer name of the 7. It allows for it, but what is you can send a bid and open bidding process for a domain name shorter than 3 letters, but it allows for me to see your bid once you reveal it, and then invalidate your bid and get 50% of the assets to me, and 50% is returned to you. And that's the process of discouraging the registering shorter names, because you will lose money if you do, so nobody likes that, so nobody actually registered. And most of the user interfaces basically disallowed it. Do you? Yeah?
So if each transaction on Ethereum is public, and you bid a certain amount of Ethereum, how do you hide that amount?
Mm-hmm.
If you understand.
Yeah. So the.
Do you give that Ethereum already in the beginning of the process of bidding, or do you somehow, how do you hide that amount of Ethereum?
First of all, when you do a bid, the domain name and your offer is encrypted, and when you send the bid, it's basically encrypted with your own.
That you did.
You don't. Yeah, you actually send it and it's locked in a contract. But when you open up a bidding process, a new contract is deployed, actually 3 of them, and the contract uses some kind of smart mechanisms to hide the trail. But you cannot read from the transaction for which domain the bid went. And you always send higher amount than actually your bid, so you kind of have that layer of hiding. But even though if you go to look at transaction, you don't see this bid went to this domain because the process encrypted. When is the reveal period, you use your own private key to actually reveal and decrypt your bid, and then it's revealed for what domain. So they're using some smart techniques which could be improved, but currently there is nobody succeeded in cracking the thing. What they doing is there is a list of known words, and you know the hashes that will result when you encrypt it. So there is a way to know for known words when the bidding start process. Yeah, it's not a vulnerability. It's basically design thing of the process. But it's a good process. You know, it works.
So if the domain is free, I can claim it. If the domain is free,
Yeah.
I can claim it,
Yeah.
or I can put a bid on it. Like no other bid, I can give it to an auction.
If the domain is free and the auction is not in
I
process,
can make an auction.
you can start an auction
Okay.
and start with your bid.
So currently, I can like take as many as possible.
Yeah, there are
domains and just put auction. All of that.
yeah, there are many bots that do just that thing. People are invested like thousands of Ether. Huh?
It's not regulated.
No, it's there are some videos that I can share with you if it's okay. I think thousands of domains are already registered. I mean, when you dig through the transaction, you see there are just accounts doing only that. You know, daily opening. When we were buying our own domain, thepowerplay.eth, one auction actually was opened and nobody gave a bid on it because some bot opened for some reason auction for that name, and we were totally scared. Oh my God, we lost our domain. But fortunately, nobody made a bid. Then in the next day, when the process was closed, we opened a new bidding process and put substantial amount of money in it. So we are sure that we got the domain. We got it for 0.01 Ether. Our fears weren't.
Important thing to say, if there's no second highest bid, if there's only one bid, you get it for the lowest possible.
Yeah, it's the 0.01. Yeah, even if your only bid is, let's say 50 Ethereum, you get it for 0.01.
Is it yours forever?
No, currently no, it's yours until 2019, when we will see how to distribute the domains in the next batch when we are smarter. So currently it's just a temporary bid, but when it's yours, you will have some better option to claim it in the next line. The amounts that you used for the bidding in the auction is basically locked in a smart contract. At any time you can give up the domain and the contract returns the amount money to you back. So basically the money doesn't go to anybody, it's locked in the smart contracts as long as the domain is yours. When you transfer a domain to somebody, which you can do, you actually give him the ownership of the bidding. You can actually do it on 3 layers. You can give the bidding rights on the amount. You can do the domain ownership, but keep the bidding rights, and you can give subdomain ownership. So you can basically do your own domain and make some kind of register for the subdomains and write up a smart contract. You have some nice ETH domain like programs.eth and write some kind of smart contract that will allow people to buy subdomains of your domain. So it's beginning of this year. It's really cutting edge technology, and you have many areas to be creative in this Ethereum name service. Yes, please.
Ethereum network fee for resolving domains.
What?
Who is paying the Ethereum network fee for resolving, for executing the smart contract which are resolved?
Well,
Please, one thing, could you, for the live stream, repeat the question always?
who is paying for the resolving of the domain? With smart contracts, writing data to the smart contract is paid, but reading data from the smart contract is free. And when you're resolving, you are basically just reading what's stored in for this ID here. So basically, it's reading is free, writing is not free. When you change state, you pay. And this is, yes?
If I understand it correctly, you translate a symbolic address to Ethereum address for your system. So what's the difference between your system and some other already available systems like Etherchain, which allow you to browse through contracts and their deployed addresses?
Yeah, but what's the difference between Etherscan that allows you to browse it?
Some kind of registry which is readily available free of charge.
Yeah, but this is not a registry. This is basically a blockchain explorer. I must know the exact hash to find to get the resource that I'm looking for.
You can register a contract name. So, for example, you have a contract which is named.
Yes.
Then I can search for your contract by name and get the same address through an HTTP interface.
Okay, but if I'm building an application that will do some kind of resolvement for my app, should I lean on Etherscan to be alive or Ethereum blockchain to be alive? So I understand it's you can hack it using that kind of system, but this is the idea is standardization. Now the whole industry to know how to do things and make it as much resilient to attacks as possible, and that's why the ENS system is kind of valuable. More questions? Yes.
You're basically staking your Ether to own a domain temporarily. Who pays for the state change if your Ether is returned to you once this expires? So who pays for the initial state change?
The domain owner. So you call the functions that will set up the when you get your new domain, it's up to you to set up the resolvers and set up the amounts that set up the data that will be resolved. So it's up to the owner of the domain to pay for the fees for the setting up the whole process. Once it's set up, it's only read.
And if I redeploy the same contracts, who determines the order of execution? Like if I redeploy my contract but change the rules slightly and allow people to register the exact same thing, ICO.powerplay.eth, which will resolve first?
If I understand your question correctly, you are asking me if two transactions that change the same state are part of the same block, which will be the order of the execution?
The exact clone of this system.
Uh-huh.
And I basically try to do the same thing.
You deploy the whole Ethereum name service.
Yeah, the whole thing with
Yeah.
minor conditions edited to my benefit.
Okay.
Which system determines that the originally intended domain gets resolved and not the one that I set up in my...
Well, if you deploy on your own contracts, it will be deployed to totally new address. And only you will know where that resolver and the registry is, and you'll be the only guy in the world that knows that there is a registry on that address. With DNS, that address is public and known to the whole community. So you can have two exact systems, but we are only using one of them. So it's a consensus thing. We decided that this deployed contract on this address is our registry, and you can do it by yourself also on the main network, but you should communicate that to your community and say this is mine, and we will do it better because of reasons. Yeah. So this is just small example of usability of Ethereum name service. This is if somebody recognizes my Ether wallet, which is some kind of easiest way to open up accounts and Ethereum and stuff like that. If you're using my Ether wallet, watch out, there are a bunch of phishing sites that have slightly changed domain that will steal your Ether. So I won't share the domain, find it by yourself. So I'm not sure which is the we're done. Golden, yeah, okay, sorry. And this is something that we used. We didn't need to contact my Ether wallet to enable this thing. We just registered our subdomain ico.dapowerplay.eth, set a resolver to resolve to our crowd sale contract, and anybody who goes to the my Ether wallet and types in ico.dapowerplay.eth will get our contract. We for our ICO we work with co-founded I'm not sure, have you heard about Co-Founded? They're kind of, let's say, startup accelerator for ICOs. It's a Slovenian project, and their ICO was worth around $12–15 million. It was like a year ago. And they're a great team of people that helped us work on our ICO, and we are the first co-founded project with ENS support enabled. And that's about it from me. So we are the DA PowerPlay, as I said before, the most crowdfunded project in Croatian history. And since today at 5:55, so I came here at 6:15 because we were just wrapping up the process. So we will continue to work in the following years, and I hope to see you more and more people in this kind of numbers. Thank you.
Okay, for any chance, any additional questions for? No? Okay, great. So this actually concludes our non-demonstrative part of the kind of our workshop. And yes, you are free if you want to go. Yeah. Run. Okay, so what we'll do now, and it will just take a short little while, it will be around 10 minutes, we'll give you an in-hand demonstration on how to write a smart contract. We will actually write a super simple, very primitive, no auction-based example of what Nikola just told us about. We will write a name resolver for the Ethereum network, and you will see just how easy it is to actually write a very distributed application on the Ethereum network. And as I said before, something like this would have taken thousands of hours for the hundreds of engineers, but thanks to the Ethereum network, we were able to demonstrate something like this in front of you today. So without further ado, I'm just gonna get to it. So this is gonna be a live coding session, so please forgive me. And yeah, let's go. So first of all, I think the big thing for software developers here to understand is, and I do actually, okay. Sorry, live streamers, it's very difficult to write and hold a mic, but just follow along. Okay. Ali fali nam kabla. Okay, so no, we're a bootstrapped operation. This is the first one. Next one is at Wembley Stadium. So, okay, so we will go to the Remix OS, which is a thing. Wow, Chinese. Great. Not Remix OS, Remix IDE. Okay, so Remix. Yeah, sorry. I never thought it was an OS. Just to be clear. The ball started rolling. Okay, we got everything set up. So how is the? So half of the screen is not available, and the JavaScript is in an infinite loop. Yeah, I told you it was gonna be a live coding session. Those always suck. Okay, so what we're gonna do now is we're gonna leverage the power of the Ethereum network. So as I mentioned, the Ethereum network has a Turing complete virtual machine built into it. So you're able to program any type of application you want. And you're just gonna see, so I wanna kind of kindle your imagination to see just how simple and easy it is to do. So most people, when I tell them about, oh, you can build decentralized applications that run on thousands of computers all around the world, simultaneously verifying transactions, making sure that nobody can attack it, non-hackable, kind of can't do anything with it, they're always scared. They think, oh my God, I'm gonna need 100 engineers for 10,000 hours. But actually, we can write it in just a couple of lines of code. So this is not the only programming language for the Ethereum network, but it is the most famous one. And I'm 99.9% sure that everyone who's written a smart contract, actually, if they have it in production, they wrote it in this language, which is called Solidity. So Ethereum is a virtual machine, and you can build any language on top of it. This is just the most famous one for now. So we start by doing, you probably don't see it well. Should I make it kind of, okay. This is better. Okay, so we write, for the first thing, we define a contract. So this is the smart contract part of the contract. We'll define a contract, we'll call it blockchain DNS. And so our contract, what it will do, for every name, it will resolve some other string. So literally anything. It's not a real DNS, but let's say for my name, I want it to resolve to my website. And we'll do something like that. So I'll write a function called blockchain DNS. And I'll currently have it take no parameters. And in this constructor, you're actually calling this function when you're deploying the contract to the network. So if, for example, I wanted to have it be a centralized DNS rather than a decentralized, I could do something like this. I could say address. Address is a type here which represents the Ethereum address, which just Ethereum address. It's merely an alias for a 32-byte string. So I'll say address owner, and here I'll say owner equals message.sender. So message.sender is an exposed variable which always resolves to the person that called the function. So remember, once you deploy your contract, it's not like an application on your phone. Once it's up, anybody can call the code. So anybody can call any function. And you will always have this variable, message.sender, which will resolve to the address of the person that called the contract. But for now, we actually don't need an owner because we want our DNS system to be decentralized. So what we'll do now is we'll make a function which is called register new pair, and it will take. Actually, you shouldn't do it the way I'm doing it now because it's going to be expensive as hell if you use proper strings. But we're not here to optimize, we're here to learn the basics. So nobody be mad at me if you're a Solidity developer. So we're going to do it like this. String, kind of let's say key, and string value. So we're going to have a pairing here, which is called a mapping in Solidity. And we're going to have a mapping from string to string. And this mapping will be called, let's say, what should we call it? The addresses. Okay, so we have our addresses, and I'll do the following. Every time somebody calls the register new pair, what I'm actually going to do is this should resolve from address to string, and this should be an address. Okay. So what I'm going to do, I'm going to make my Ethereum address resolve to some string. And what I'm going to do first here, I'm going to do this. I'm going to say require that the addresses on a position msg.sender is different from address on a position 0. What's it say? Operator not compatible times of string.
Underscore.
I forgot an underscore somewhere.
The right address has no other underscore. Left address has underscore.
No. The right address shouldn't have an underscore. What?
Brackets.
Brackets. What?
No bracket.
Okay, one at a time. Okay. Let's just say here. If addresses on a position MSG, we would never finish this live debugging session. So if addresses on a position MSG.sender they resolve to string. Okay. If they're different than an empty string, which is by default, which the string type resolves to by default, we will throw. What this means is that, oh my god, not compatible with strings, so okay, whatever. Okay, I know a solution. We'll make a struct called, we'll make a struct called storage, and we'll say the boolean exists and has string resolver, and we'll make our mapping resolve an address to storage type, and then we'll just say if addresses on a position msg.sender, if it exists. Okay, so what this means, how do we interpret this? If on a position of the MSG sender, there is already an address, we forbid the person to register a new address. So they cannot register a new address as long as there is already an address created at their account. But if this is not the case, we will do the following. So we will say, and also we will make a check. If msg.sender, actually we don't need to do the check. Okay, so what we'll do is the following. On addresses, on a position of msg.sender, we will put the key. And I just realized we don't need this because we have msg.sender. Okay, so now what we've done actually on the Ethereum blockchain, we registered a key, a string, to resolve to our address. And if we want to read this, we will say read address, and it will
Put the struct there.
What?
Instead of key.
Yeah, I should put a struct. Thanks. And key. Okay. And now we'll get a function which actually, for our given address, resolves the key we associated with it. So we'll have the addresses. This should be, and we can any function that reads should be made constant. So what this means, if your function is constant, it's a modifier which means that it's free to call. You don't have to pay gas. But you remember earlier I spoke about gas. So if your function is a constant, it just means it's a read-only function, and it doesn't really need to spend gas, because as Nicola mentioned at some point, if you're just reading from a function, there is no requirement for you to actually pay gas. So what we'll do here is if on MSG sender, if it's false, we're gonna throw, and else we're gonna return and giving us a hard time. Expected token left brace what return. I think. Okay. So undeclared identifier. Yeah, typos everywhere. I warned you at the beginning. It's a live coding session, and one for which I haven't prepared for. So okay, you will notice this is 30-ish lines of code, and compared to something like the Ethereum naming service, this is extremely primitive. Very, very. No auctions, first come, first serve, no complex resolving types, no resolvers, no multiple contracts, no inheritance, no nothing. But this is just an example. If I were to use this contract to register my address, it would be computationally just as expensive to overwrite my address as it is to falsify an Ethereum transaction. You would need the impossibly large 51% of hash power on the Ethereum network just to fool my 28-line contract. So this contract doesn't do much. Of course it doesn't do much, we wrote it in 5 minutes. But it shows you the power which you have at your disposal as a software developer. If you're trying to deploy smart contracts, this is all you need. They are not contracts in the legal sense of contracts. They are self-executing code. Nobody can cheat it. If I wrote this, register new pair, nobody can write over my pair. Except if they have 51% of the power of the network, which nobody has, and it's highly unlikely that anybody will ever have. So this was meant as a demonstrative example. If you have any questions, now would be the time to ask them, and hopefully this will inspire you to go out and write your own smart contracts and join us in Croatia in building a healthy, vibrant community of Ethereum developers. Yes?
Why did you need to build the storage structure?
Okay, so Okay, so this, I didn't have to build it. I could have structured my code differently. I'm just live coding now, and it's kind of, when you define a mapping in Solidity language, actually all the mappings are present, kind of in an abstract way. So every mapping that hasn't been initialized is always initialized to its default values. So you can always create a struct which has this kind of exists bool to resolve. It's kind of an anti-pattern, but it's an easy pattern to understand for live coding purposes. Yes?
Remix ID, is it also available for Windows and Linux?
This is a website. Yes.
Thank you.
How do you test this? Do you need to pay gas to test it?
Okay, yes. If you're gonna test it on the main network, you need to pay gas. But as Nicola mentioned, he deployed his contract on the Ropsten test network. So there are several test networks available on Ethereum. So the most famous ones are Kovan and Ropsten. But you are also able to run your own private chain on your computer just for testing purposes. And I always do this. I would recommend you Google test RPC. So test RPC is kind of a simulator. It's not a real blockchain, but a blockchain simulator which you run on your computer and just kind of like fiddle around with. Yes?
What kind of stuff can you do in constant functions?
In constant functions, you can only read. You cannot change state. So any variable that's outside of the function is considered a state, and anything that's outside a function you cannot modify with a constant function, because the constant function needs to be free, and only read-only functions are free.
Can I call this for my smart contract?
Yes, you can call
How
other
does that
contracts. So you have a delegate call function, which actually takes as a parameter the address of a contract and its application, something called an application binary interface. And what it does is it sends a certain type of data to the contract, and this is very common. This is actually expected. You have plenty of smart contracts which are merely services for other smart contracts used as libraries.
So they have an address?
Yes, yes. Each contract, when you deploy a contract, you get back an address, and this contract lives on that address.
Can I ask a question?
Yes, just as a service.
I'm guessing that from here you can read any entry from the blockchain, but can you read outside of the blockchain?
No, it's impossible. Actually, if you think about it, it's logical. This runs on the blockchain, and there are services currently which enable you to gather outside information. They are called oracles, but they are always using centralized software to write to the decentralized Ethereum network to provide outside information such as stock prices, weather reports, political news, which can be used as an API to access new data. But a new generation of oracles is being developed, ones which use a reputation system and an incentives-based kind of collateral damage system, where you can give good information to an oracle and it will reward you with ether, but if you give bad information to an oracle, it will burn your staked ether. So it's all based on a game theory approach, mathematical approach to human psychology. If you have an incentive to help the network, you will join the oracle and provide outside information to the contract.
What happens with the infinite loops within the constant functions?
Yeah, you can run infinite loops in constant functions, that no problem, but well, why would you? I mean, it doesn't cost anything to anyone.
Precisely, because you never run out of gas.
You never run out of gas, but if you're reading, think about it. In order to have the blockchain, you need to have the entire blockchain downloaded on your computer. So you're essentially just infinitely looping a function on your own computer.
Because you're reading just from your own.
Yeah, from your own computer.
Yeah,
but
okay.
every time you change the state, this function has to be run on every computer in the network. Yeah. So if you're reading, you're just wasting your own processor. Yeah.
Let's say you want to charge for this service for reading. The minimum amount I want to provide the service to charge for, instead of defining the constant, how would you charge for this and define the exact price? Let's
Charge
say
for reading. Okay, I wouldn't make it a constant. I would make it pay. Okay, syntax I like, but anyway, you can make functions payable and you can send ether to them. And there is a variable.
So you can say payable and the amount.
Yeah, you can do this. It's the msh.value, and it actually gives you in an integer the amount of ether that has been sent to this function call, and you can always check, is the amount of ether greater than some amount, and then allow or throw the function.
And then pretty much you need to communicate the other channel, let's say documentation, how much?
Yeah, of course. Yeah, it's generally all of the functions and smart contracts on the Ethereum network are open source. If you try to publish a closed source solution, it's very easy to decompile, and the functions themselves are not very useful without being open source because it's maybe not as useful to think of them as classical functions. So everything is open source and everybody knows what's happening when you're calling the function.
Post Oracle, if you can read something through an Oracle from the outside, can you post something on the outside like Twitter?
Yes.
Tweet?
Yes, you can use oracles for that, but what oracles do, let's say you want to post to Twitter, and you actually write to the Oracle smart contract, which is confined within the blockchain, and then some person has to build normal software which will read that contract and post to Twitter. So, and they do that because you award them Ether. Yeah, everything is money based on the blockchain, so everything is value based. Every decision, every type of work you do is presumed on the fact that you are a rational actor in a behavioral economic model. So actually it's expected for every smart contract which is worth its salt to actually have more of the time invested in the behavioral psychology economics part than in the technical part itself, because that's the backbone and the bread and butter of the blockchain itself. So yeah, you can do that, but it's a whole different paradigm than what has classically been done.
Can you withdraw your contract? Like if you make
yes,
a contract that's
yes, you can delete contracts, but you have to have a special function which allows the contract to be deleted.
If you don't have that, you can delete it.
No, if you don't have that, you can delete it because it's kind of a guarantee to your contract users. If you don't have that function, you can't delete it. So you're actually happy that you can't delete it.
Why? But
because nobody would invest in your contract if you could delete it.
So you're telling me that like the contract that many people use,
yes,
they probably don't have a withdraw function.
Sometimes they have. They generally have migration functions.
Oh, okay.
They generally have migration functions for a new version of the contract, and sometimes they have a decentralized voting system in place, which allows the contract stakeholders to take a vote and decide whether the contract should be migrated or not.
One just quick technical question. The 16th line, is that the null pointer exception or what? Like
no. Every mapping, if you make a mapping, every item already exists.
Like it has the default object.
It has the default values if it hasn't been initialized. So, but it doesn't have to be that way. You could. There's already a project building a C# compiler for the blockchain. So if everyone doing C#, you can wait for that. But Solidity is just one of the languages, and it's an early attempt. It has its flaws. It was actually built to be a type-safe system mimicking JavaScript for the purpose of luring in developers. So the early goals were to make the language simpler, human readable, but there are already attempts. You can use the LLL language, which is a variant of Lisp. So if you're a Lisp developer, you can always use the LLL, or you can use Serpent, which is a variant of Python. So yeah, the space is currently evolving. As I said, Ethereum is just a virtual machine. You can build any language on top of it.
What happens if you run out of gas? If you don't commit?
If you run out of gas, all the state changes that have been committed in the function are rolled back. So if you have changed the address but haven't made it to the end of the function, all of your changes are rolled back. And your gas is gone forever.
That includes other calls to other functions as well. The entire transaction.
Yes, the entire call. So you have to.
It's basically all or nothing.
Yes, it's all or nothing. But you will always you have estimators for the gas cost, and you are always advised to make the maximum gas limit much bigger than the gas limit needed, so that you can call it faster. And there's also some mechanisms for having your function call included faster on the blockchain, but that's kind of advanced a little bit.
But you can never know, right? It's kind of a halting problem.
Yeah, it's actually just the basic example of the halting problem. So for those of you who don't know, the halting problem states that it's impossible in a logically sound system to deduce whether a Turing complete language will execute forever or will stop at some point. So you cannot build a program which will evaluate another program and decide whether it will stop. So this is the need for gas because of the halting problem. Yes?
Will the C# compiler be better in solving the string problem?
In solving the?
String problem. It's very expensive.
No, strings will always be expensive. So storage is expensive. You need to think about the fact that when you write this, you're writing this on hundreds of thousands of computers all around the world. So one string is in fact 100,000 strings. So storage on the Ethereum is always expensive. And even the biggest contracts are rarely big, maybe 150, 200 lines of code. So these are not meant to build, I don't know, a 3D renderer or whatever, although you could, but they're not meant for this. They are meant for a simple distribution of value functions, which kind of help you in the point of this is to work in tandem with normal software. So you use this to verify, and then you use normal software to compute. I think we had a, yeah.
Yeah, so I'm pretty unaware of how this all works. So you need to deploy this contract.
Yes.
How do you actually call the functions in this contract?
So you have, and just as Nicola said when he told you about the ico.dapowerplay.eth, so you have an Ethereum address to which that contract has been deployed. You call that address, and depending on your Ethereum client, you have a certain kind of parameters which you enter, and then the client calls the Ethereum network on that address with these parameters, and the rest is. And you broadcast this message to the network, and the next time the next block is mined, your call to the function is confirmed.
So they're all public functions.
Yes. You could make private functions, of course. You could make private functions, but all that means is that another public function will call them at one point. Yeah. Okay, and this will be the last question.
Is there a limit on size of it?
No. The limit is the amount of money you hold in your pocket. So for the bigger contracts you pay more, for more complex contracts you pay more, for a plurality of contracts you pay more, and yeah, nobody's preventing you to write 100,000 lines of code, behemoth, artificial intelligence, I don't know, renderer, but you will run out of money very, very fast. And it will be very, very slow. Remember this, at its current state, the Ethereum virtual machine runs somewhere in the lines of a pocket calculator by the computational power. But you're not using it for the computational power, you're using it for security. And computational power is always offloaded to a different service, a centralized service, and you're using this to verify that everything has happened the way you wanted it to happen. So thank you all very much. I would like to invite you to go downstairs, enjoy some pizza, beer, and non-alcoholic beverages, and mingle with your blockchain colleagues, discuss business, make some money.